Hello, algebra students. We're ready for section 3 of chapter 8. Before we start in on multiplying polynomials, let's make sure we can multiply a monomial by a polynomial. All of these review problems are practicing that, and then of course number 4 you can solve, and the reason you can solve number 4 is because there's an equal sign. But the hardest one on the review, I believe, is number 2, and I'd like to work that one with you, where we have to distribute a 3/4 y times the 3 terms inside of our polynomial, making it a trinomial. So this is an understood 1 in front of our x squared y, so that's just going to be 3/4 x squared y, and y make y squared. But then for the next one, we're going to have to say, what is 3/4 of 8? Well, 4 goes into 8 2 times, so that's going to give us 6. So when we say 3/4 y times our second term, we're going to end up with 6. And it's x and then y squared. It's going to make y to the third. Minus, and then again, we have to take 3/4 of 16, and 4 goes into 16 4 times, and 4 times 3 is 12. So that's going to make minus 12, and don't forget the y, so minus 12y. All right, so you finish these other review problems, and I'm going to start in on our new material. All right, when we are multiplying polynomials, we are going to end up with a quadratic expression. Now, what does that mean? Quad means 4, quadratic expression. It's an expression whose highest power is 2 when it's written in standard form. So it's going to be ax squared plus bx plus c, where a stands for an unknown number, b is another coefficient, and then c is the constant. So when you have x squared, let's make those red, and x, our highest power here is 2, so that is a quadratic expression. So everything we're about to do with multiplying polynomials, we're going to end up with x squared in our final expression. Distributive property is the name of the game. Distribute, distribute, distribute. That's what I want you to remember as we work through these. Now, I'm going to show you a new method. It might be new to you, called the FOIL method. And this is how it looks. And it's really funny. I've heard this called the little FOIL man, because as you multiply your first expressions, they have those highlighted in red here. It makes like an eyebrow. And then the O stands for the outside expressions. The I stands for the inside expression. And then the L is, of course, your last expression. So when you do your distributive arcs in this way, it looks like a little man. See, that's his eyes and his nose and his mouth. You can put a little bow tie on him if you'd like. Give him some hair. Okay. Whoops. So that's the FOIL man. Now, I said, what's the name of the game? Distributive property is the name of the game. So I'm going to look at the very first one, and instead of concentrating on our new FOIL method, I want to just show you basic, bare bones, how to work this problem. I need to take my y and distribute it to everything on the other side. So y times y is y squared. Y times a negative 4 is going to be negative 4y. Then I need to take my 8 and distribute it to everything on the other side. So that's going to make 8 times y, which is positive 8y, positive, didn't want to hold. 8 times a negative 4 is a negative 32. Combine like terms, y squared minus, or excuse me, it's actually going to be plus, because you're going to subtract. The signs are opposite. Keep the sign of the larger term. So positive 4y minus 32, and I'm finished. And that is a quadratic expression because I have y squared is my highest power. That's it. That is what you have to do in this lesson. Distribute and distribute again. But they don't call it distributive property. They call it the FOIL method. So let me show you using the little man we're going to do our first term, which is 2x squared. Then I'm going to be blue like they are. I'm going to do my outside term, which is the same thing I did over here. I said y times -4. That was the second term that I did. So that's going to give me 12x. Then in green, my inside term, 1 times x, is just going to be 1x. And that, again, is what I did here. My inside terms, 8 times y was 8y. And then my last is in yellow. Let me pick a yellow. 1 times 6 is going to be 6. So I've made a little man here, and I have followed the FOIL method. So first, I did 2x times x. Outside was in blue, inside was in green, and then last was in yellow. And basically, I'm doing the distributive property, 2x times x, 2x times 6. And then I did the distributive property with 1 times x, and 1 times 6. So if it's as easy as the distributive property, why in the world did they have to name it a new name called the FOIL method? Well, it's going to become much more clear in our upcoming sections. So bear with me. I need you to understand the FOIL method, but you can always check yourself by doing the distributive property. So let me go ahead and finish this problem. 2x squared, 12x and x makes 13x plus 6. So now I have it simplified to its simplest form, my quadratic expression. So let's leave 3 and 4 for you to practice on your own, knowing that you're distributing, and then also try doing FOIL and let me know what your questions are tomorrow when we come to class. And then on the back of this sheet, you can pause if you'd like and go ahead and finish those two before we talk about the back. Our first problem is a patio that is in the shape of a triangle, and that picture is shown there. And they want us, it's built in Lavalley's, I'm not sure how you say that word, in the Lavalley's backyard. They have a different name from any name I've ever heard. The dimensions given are in feet. And the area of a triangle is, of course, 1/2 the height times the base. So 1/2, let's write that down. Area of a triangle is 1/2. I always say base times height, so I'm going to write it the way I usually say it. Same thing, height and base and height, that is commutative. It doesn't matter which order you put those. Write an expression for the area of the Lavalley's triangular shaped patio. All right, well, they've given us the base here is 6x plus 4, and they've given us the height is x minus 7. So the area here is going to be 1/2 the base, 6x plus 4, times the height, x minus 7. So I'm going to leave my 1/2 sitting outside while I take care of doing the FOIL method. So 1/2 stays there. And now I'm ready to say 6x times x is 6x squared. 6x times -7 is going to be -42x. 4x, whoops, I'm supposed to do that one underneath. That's the nose. 4x. See, I often just do the distributive property when I'm supposed to be foiling. And then 4 times -7, and I'm doing FOIL on purpose. I want you to see the pattern. These middle two terms are very important coming up soon. And 4 times -7 gives us a -28. So I'll combine my like terms. My 1/2 is still there. 6x squared has no term like it. -42 plus 4 is going to leave us with the -38x minus 28. And now I can distribute my 1/2. And they're all even, so they're all divisible by 2. So we end up, the area of our patio is 3x squared minus 19x minus 14. And that's going to be our final answer, because that's the best I can do for the Lavalley's. All right, I'm going to leave you the rectangle to work very similarly to that problem. And then look at this last section. Look what it's called, the distributive property. How about that? So the FOIL method is the distributive property. Again, that's the bottom line. That's the main thing you have to know to make a 100 on the test. If you can distribute and combine like terms, then you can make a 100. But this one is going to be the distributive property on steroids. What does that mean on steroids? It's going to be really big. We have a binomial being multiplied times a trinomial. So let's go back. What was the name of this section? Multiplying polynomials. So we're multiplying a lot of terms. So let's start with 3a. I'm going to distribute it to all three things. 3a times a squared makes 3a to the third. 3a times a negative 12 is going to be negative 36. A times a is a squared. 3a times a positive 1, that one's easy, positive 3a. Then we have to, I'm going to get a new color. I highly recommend getting a new color. You might even do these distributive marks on the bottom so that you don't get lost in all the markings, especially if you don't have colors. So 4 times a squared is 4a squared. 4 times negative 12 is going to be negative 48a, because there's not another a to combine. And then we have 4 times 1 is 4. So let's highlight our like terms. There's no other 3a to the third. There's no other a to the third, but here's a squared and a squared. And here's a, and then there's no other constant. So our final answer is 3a to the third, negative 36a squared plus 4a squared leaves us with a negative 32a squared. 3a minus 48a leaves us with a negative 45a, and then the positive 4 is all alone, and that is your simplified distributive property. It is not a quadratic expression. Why not? I'll let you tell me how come I cannot call this a quadratic expression tomorrow. And I really think, well, I started to say I'll leave the last two for you, but I'm just going to leave number 3. Let me work this one, since we have to do it 3 times. I'm going to distribute 2b squared, then I'm going to distribute 7b, and then I'm going to distribute 9. Ooh, that's a lot of marks. So let's see how it looks. 2b squared times b squared makes 2b to the fourth. 2b squared times a positive 3b is positive 6. Oops, this was b to the fourth. Positive 6b to the third. And 2b times negative 1 is negative 2b squared. Then with my blue, 7b times b squared makes 7b to the third. 7b times 3b makes 21b squared. 7b, negative 1 is negative 7b. Now with my green, 9 times b squared is 9b squared. 9 times 3 is 27. Don't forget the b. And 9 times a negative 1 is negative 9. So if I didn't have highlighters at my fingertips, I might go through. I only have 1 b to the fourth, so that 2b to the fourth is going to be there. I only have 1 constant, so I know it's going to end with a negative 9. And then I might go through and underline 2b to the third, 7b to the third, up to 13. There's no more b to the thirds, so 13b to the third. You could double underline your b squareds. Negative 2, negative 21 makes negative 23, plus 9 is going to make negative. Okay, lucky for me, I have this worked out on a piece of paper, and I realize I either didn't write it, or if we rewind the video, we might find out that my crazy little screen didn't catch that plus sign. Sometimes when I write real fast, the marking doesn't always hold. So that's supposed to be a positive 21. So positive 21b squared with 9b squared makes 30 minus 2 is going to make a positive 28. And I was writing in black. Positive 28b squared. So see, all of those little signs are very important, and in my haste the screen didn't pick up my positive, and it makes a huge difference. So now I'm underlining, so I'm ready for 3 underlines. I have a negative 7b and a positive 27b. When you combine those, it leaves you with a positive 20b, and there's my minus 9, and that is my final answer, and that is why it said it's going to be the distributive property on steroids. And I know you can do it. Yes, you can. Have a great day.